Okay, guys, so this is Mr. Rafaba again. We are continuing with our cubic functions for prelim 2023 all provinces. So now we are on Mpumalanga. This is what Mpumalanga was faced with. So they're saying in the diagram, the graph of f of x is dead, so they give us everything, and A, B, C, D are x-intercepts, of f, that's A, B, and C, and G is a point on the x-axis such that TG is perpendicular to the x-axis, so we can see it's there, and D is the y-intercept. So they are saying find the coordinates. Okay, find the coordinates. Find the coordinates if, not happening here. Okay, why has it moved there? Oh, okay, I want it here. That's fine. So find the coordinates if B. Already we have the factor, because remember here this is f of x equals to, what is our function? -3 negative x cubed plus 5x plus 8x. Is it minus 5x? Or plus 5 plus 8 plus 5x squared plus 8x minus 12. So we know if we have an intercept, if we substitute, like you see here, they said if b equals to 1, that means we already have one x-intercept. That means my expectation is that when I substitute 1 cubed plus 5 1 squared plus 8 1 minus 12, I'm not going to do that. You must get 0. So that means your x will be 1. And if you want to make it a factor, it's going to be x minus 1. So we're just going to do quickly. They say we must solve the coordinates of C, which is another x-intercept. So we're just going to use a much more quicker method. So this is what I put. This is my factor. My factor that I found, the first factor is 1. So if maybe you substitute 2, 2, 2, then you get 0, you can put a 2 there. And then I do find the, what we call, what are these? The coefficient of x cubed is minus 1 plus 5 plus 8 minus 12. Okay, so let's say for instance the equation that we had here, you see this one does not have the x squared, so that means it's going to be x cubed plus 0x squared minus 3x plus 2. So the coefficient will be 1 plus 0 minus 3 plus 2. That's how. So I put them in the sequence. It must be x cubed, x squared, then x, then constant. So here I don't have the term that has x squared. It means there's a 0 as a coefficient. That's why it cancels out. So it's very much important. Otherwise, you must stick to the method that you know. Okay, if you don't understand this one. So here, whatever that I have here as the first factor, I will drop it down. I'll drop it down here as minus 1. Or rather, let me just write the coefficients up there. Let me write them up here as minus 1 plus 5 plus 8 minus 12. So I drop the minus 1. All the time, this first one, you drop it. If it was 2, I'll drop 2. Therefore, what do you say? You say this multiplied by 1 is going to be what? It's going to be negative 1. So negative 1 plus 5 is going to be plus 4. So 4 times 1 is going to be what? 4 times 1 is going to be 4, isn't it? So 4 plus 8 is going to be positive 12. So 12 times 1 is going to be positive 12. It's going to be positive 12. So this is positive as well. So this positive 12. So positive 12 minus 12 is going to be a 0. Okay, it's going to be a 0 there. So therefore, when it's a 0, all the time, for you to be sure that this method is giving you correct things, this guy must always be 0. If it's not 0, it means there's something wrong. You can use that method of bx, what. But yeah. So, and then, now this one, remember now my factors. What are my factors now? My factors, my first factor is this one, which is x minus 1. My second one is going to be negative x squared plus 4x plus 12. So whatever I found here, x squared, x, and constant, because this one is always 0. Therefore, 0 equals to x minus 1, or 0 equals to minus x squared minus 4x plus 12. All right. So you can use quadratic formula to solve for this one. So this one, my x is going to be minus 1. It's going to be positive 1. So you can use quadratic formula to solve for that one. So it's going to be minus, my b is what? Is 4. And then plus square root of 4 squared minus, is b squared minus 4. My a is minus 1. And then my c is 12 over 2a, of which 2a is minus 1. So my first value is negative 2. So another x is minus 2, or my other x is going to be minus here. So it's going to be 6. So these are the 3 x values that I have. So the one that can be attached to c is going to be this one. So my c, my coordinate of c is going to be 6 is to 0. So those are my coordinates of c. So I hope you understand that. So this is going to be minus 2, and this is 1 that we found, and then the other one is c. And then they say find the coordinate of e. E is the turning point. So to find the coordinate of e is not a problem. What we just need to do, we just need to find the function. So this is 2.2. This was 2.1, right? 2.1. 2.2. I'm just going to say f of x equals to minus x cubed plus 5x plus 8. 5x squared plus 8x minus 12. So now I'm going to derive and find the gradient at any point, plus 10x plus 8. So now remember, at stationary points I know the gradient is 0. So I'm looking for x values where the gradient is 0. X values where the gradient is 0. Okay. Therefore, you put that on the quadratic formula as well. So my b at this point is 10. My b at this point is 10. And then my a is minus 3. And then my c, what is my c? Is 8. My c is 8. My a is minus 3. So the first x value is x equals to 4, or x equals to what? Let's put a plus there. Minus 2 over 3. it's minus 2 over 3. So the one that is equivalent to E is going to be the one of 4, because this is minus 2 over 3. Okay, so now I want to know what is the function. So I'm going to go for 4. So f of 4, you substitute 4 everywhere there. So this is negative 4 cubed. This is negative 4 cubed plus 5 of 4 squared plus 8 of 4 plus 5 of 4 squared plus 8 of 4 minus 12. So that is 36. So this is 36. So the coordinates of E is 4:36. So those are the coordinates of E. So 2.3. For which values of x will the function be concave up? So for concavity, we need the point of inflection. So normally the point of inflection is the mid value between the two turning points. So already I know this is 4, and then this is minus 2 over 3. So I can plus them and divide by 2. It will give me the middle number. I can just say this plus this, and then I divide it by 2 to find the x value of the point of inflection. Point of inflection. I just need the x value. So I will say x equals to negative 2 over 3 plus 4, all divided by 2. Okay, so this is negative 2 over 3, negative 2 over 3 plus 4, all divided by 2. So that is 5 over 3. That is 5 over 3. So that is my point of inflection. That is my point of inflection. We can put it maybe somewhere here. That is my point of inflection. So on this side, you see it's smiling, and then the other side is frowning. So where it is smiling, we say it is up. Where it is frowning, we say it is down. So this is 5 over 3. So where it is concave, what? Up. It is less than 5 over 3. So this you can say now x must be less than 5 over 3. Another one can maybe derive this twice. You know, the method that we are normally used to. We can just get the second derivative, which is this going to be negative 6 x, okay, plus 10. Then you equate this to 0. It's going to be negative 6x plus 10. Then that goes that side is 6x equals to 10. Divide by 6 on both sides. So x equals to 5 over 3 if you simplify further. It's because 10 over 6 is 5 over 3. Alright, so it's the same as that, you see. Then now, because you found the point of inflection, you must just check where is it up and down. If it was down, we will say on the greater side, but this one is the lesser side, it's up. Alright, yeah. And then we come to the tangents. We come to the tangents. Calculate the length OG if the tangents to the curve at T is parallel to the tangent to the curve at D. All right. So now if there's a tangent here, they say it is parallel to the tangent here. These two guys are parallel. I've not drawn them to scale. All right. So if they are parallel, they share the same gradient. Okay, so what is the formula for general gradient? Let's do it. So we are at 2.4 now. We're at 2.4. 2.4. What is the formula for general gradient? This is the formula for general gradient. Negative 3x plus 10. Negative 3x squared plus 10x plus 8. So the only obvious gradients that I know is on the turning point, the gradient is 0. On any other point, if you have a straight line, guys, if you have a straight line like this, the gradient here is the same as the gradient here, is the same as the gradient here, is the same as the gradient here. But once I have a curve, the gradient here and here, they are not the same. So the gradient at every point of this function is not the same. The gradient here and here and here is not the same. But if the gradient at this point, the tangent at this point, is parallel to this, it means they share the same gradient. But I need, for me to find the gradient at point A, I must substitute the x value of point A on the general formula for gradient. So point A is minus 2. So I'll say what? I'll say minus 3 and then minus 2 squared plus, is it 10x? Yes, 10 of minus 2 and then plus 8. So the gradient at minus 2 is minus 24. The gradient at this point here is minus 24. What is the gradient at this point? Can I find it? Do I have the x value of this point? Do I have the x value of this point? Because I know that the gradient here and here must be the same for two lines to be parallel. So whatever gradient I find here, it will be applicable there. So now what do? I must find between the 2 points, where do I have x value? This one is easy because the d here, the x value here is 0 and the y value is minus 12. The y value is minus 12 because this is the y-intercept. So I have the x value here. So I can just substitute it on the general equation. So f of 0 minus 3, 0 squared plus 10, 0 plus 8. So the gradient at that point is what? Is 8. So there are 2 points on this function where the gradient is 8. But for me to find those two x values, I must substitute in this place 8 in a place of gradient so that I can find what? I can find those two other points. I'm substituting 8 in a place of gradient so that I can solve for x-intercepts. So if you take, for instance, if I take 8 to the other side, it's going to be 0, negative 3x squared plus 10x plus 8 minus 8. Minus 8. So this cancels out. 0 equals to negative 3x squared plus 10x. Therefore, I solve. X as a common factor, negative 3x plus 10, 0. So the x value, the first one is 0, the second one is 0 equals to negative 3x plus 10. So this comes up, divide by 3 on both sides, therefore x equals to 10 over 3. So there are 2 points where the gradient is 8. It is here, m equals to 8 and m equals to 8. So at this point, 0, it is this point. That will mean here, the x value of this is 10 over 3. So they say we must find the gradient, the x value of t is 10 over 3. So they say we must... This thing was not recording. This thing was not recording. So what I was saying, it cut when I was saying because this is 10 over 3, they want this distance OG. And then 10 over 3 minus 0 is 10 over 3 units. So that's what I intended to say here. OG is 10 over 3. I just realized it cut because of the memory was full. Okay, it's doing those shit things. Let's do this and this. Okay, yeah, it's no longer doing those things. What is the other question? Oh, determine the value of m if this intersects this perpendicularly. Okay, if this function intersects f perpendicularly, okay, at x equals to 5. So we must find the gradient at x equals to 5 of f. The gradient of f at x equals to 5. What is the formula for the gradient? So that is 2 point what? It's 2.5. What is the formula for the gradient? F of x equals negative 3 x squared plus 10x plus 8 plus 10x plus 8. So we want the gradient at x equals to 5. So the gradient at 10 equals to 5. The gradient at 10 equals to 5. Let me delete some of these things. I'm sorry for that. At x equals to 5. So it's minus 17. So the gradient is minus 17. So they are saying this line, it intersects it perpendicularly. It intersects f perpendicularly at x equals to 5. So the gradient at x equals to 5 is minus 17. So the two gradients of this line and this line, when you multiply it, it must give you minus 1. So what is this gradient? They want this gradient. So you're going to say what? Divide by negative 17 on both sides. So the gradient is going to be 1 over 17. Because 1 over 17 times negative 17 is going to give you minus 1. So m equals to, therefore, m equals to minus 1 over 17. Because remember, for gradients to be perpendicular, when you multiply them, they must give you minus 1. If you take, no, it's not negative. If you take this and this, you multiply, you must get minus 1. So the answer is this one. All right.